test.
Yeah.
Oh, success. Okay. Cool. Okay, I'll just get into it. Oh, perfect. Okay. Hi, everyone. First of all, thank you all so much for coming. I don't know when your last lecture was, but if it was a while ago, I really appreciate you guys staying on campus for this. So first of all, I'm Julia, and I'm part of the Part 1 team.
I'm Anna, and I'm also in the Part 1 team.
Hi, I'm Kia. I'm short. And you might have saw me in the electrical lecture today. And I'm also part of the Part 1 team.
And then we also have our other Part 1 rep who is overseas right now in the Philippines, called Camilla, and she'll was also involved in running this event. But so I'll just kind of introduce you guys to the plan for the evening, and then we can kick it off and get started. So we're going to start off with Chantal from Electrical, but we're going to probably spend about 5 to 10 minutes running through each spec. And then I just encourage you guys to think of some questions maybe during the event. And then when we disperse for some food, then you guys are totally welcome to go up to each of the speakers and ask them about any of their experiences or how they're finding it so far. So with that, I guess we'll start with Chantal from Electrical. So yeah, round of applause for Chantal.
Are we just starting the thing now?
Yeah.
You're not running through them?
No.
Okay, we'll just... All right. Hi, everyone. My name is Chantal Hayward, and I'm a Part 3 Electrical and Electronic Engineering student. And electrical engineering is actually the oldest specialisation at UOA. Isn't that such a fun fact for everyone to learn? So I guess a little bit about me before I get started. Again, I'm a Part 3 student this year. You might have seen me around campus. I do a lot for WEN. I am in content this year for WEN, so I make quite a few TikToks. And I also run the podcast. So this is not a shameless plug, but it might be a little bit of a plug. Give the podcast a listen. I also do engineering review. We had our show a few weeks ago now, so if any of you came to see that, you know it's kind of a stage show at Sky City. But yep, I do a lot of other things besides just being an electrical engineering student. I also picked electrical engineering because magic and electricity are awfully similar. It's just so interesting to me about how little electrons can create such powerful objects. I don't know. I just think it's really cool. So I guess, I actually am a bit of a traitor. I didn't start off in electrical. I started off in CompSys in my Part 2, so this was last year. But I switched from CompSys because, CompSys, lovely Anuri will be doing the presentation about CompSys later on, but CompSys is more of a combination of like firmware and hardware. So after I came out of Part 1, I kind of wanted to do a bit of both because I really enjoyed the coding paper you guys do, and I also really enjoyed the ElectEng 101. I don't know if that's a popular opinion amongst all of you. I can see someone laughing. Yeah, I have some information about that later on. But I enjoyed both of those, so I wanted to give both of those a go. I didn't really want to limit myself to just software or just electrical, but as I went through my Part 2 papers, I actually realized I really loved the hardware side more than the firmware side. And also when you do electrical engineering in your second year, your papers are identical to CompSys, so it's very easy to switch from CompSys to electrical, but it's not so easy to switch from electrical to CompSys. So that's also another thing for you guys to consider. So I guess what is electrical and electronic engineering? It covers pretty much anything to do with electricity, the big stuff from generation and transmission to the electronics used in appliances. And you'll learn a mixture of both of those in your journey through electrical engineering, and you'll find which one you prefer more. Unless you like all of it, then that's really impressive. But you normally decide which one you like the most after your Part 2 papers. So I guess some topics. ElectEng 101 is not indicative of electrical engineering. So if you're absolutely despising that paper at the moment, don't let that put you off electrical, because honestly, it's really just the fundamentals of it. And once you sort of learn those basic fundamentals, it opens up such a wide variety of such interesting topics, such as circuit theory, electronics, hardware, firmware, electromagnetism, which is my personal favorite, power systems, my personal favorite, and also radio engineering. So really, you cover so many topics, and I don't know, it's just so interesting to me. So on the slide there, it says mostly ElectEng 101 with a bit of NGen 131 and also mathematical modeling. So if you enjoyed MM1, come to electrical. We do a lot of maths, which I love, I know, crazy. So I guess what's a typical day for me? That picture up there is, that one, you can see me there. This was when we had to do a presentation for a client. For one of our design papers. I'll get to that in a bit, but we got to present to a client and my team actually won. So that's a picture of us with the client from Hella, the lighting company. But anyway, typical day. Obviously, I go to many lectures, as you're probably all aware. Lectures to cover the theory. I then have group meetings with my project partners, for our design papers. Then I have many, many labs as well, and project work. So that's like building PCBs, so like actually creating the hardware, simulations on LT-Spice, etc., creating PCB layouts, coding firmware for interaction with microcontrollers, etc., building physical prototypes, and also soldering. If you ever want to come find me, I will probably be on the level 5 labs because I cannot leave. I'm there all the time, just doing project work, but that is because I'm in 3rd year, so you do a lot more projects in 3rd year, but I'm getting ahead of myself here. Projects, yay, so fun. So in your 2nd year, your first ever big project paper will be ElectEng 209, which is designing a smart energy monitor. You do that paper with CompSys. It's kind of a mixed paper, so it's ElectEng/CompSys 209, and it will be your first introduction into what a project paper really is. It's a semester-long project, and you work in a group of 4 people to create a smart energy monitor. And it's great. It's really fun. It's very fun, I promise. But it's a lot of work, and once you've gone through 209, you will be so proud of yourselves. It really does teach you so many good skills. Then once you've done that one, you go on to ElectEng 310 in your first semester of 3rd year, which is there's 2 projects for that paper, so you do 2 of them. The first one is actually the anti-collision system, which is it's basically a speed detection system for 2 cars. So it sends a signal, the front car sends a signal to the back car to sort of tell them the speed so that they can quickly stop and prevent rear-end collisions. That was the project we did for Hella. So actually Hella themselves approached the University of Auckland and gave our paper this design challenge. So that was that picture I showed you earlier of us presenting to the client. It's really interesting how for a lot of these papers they're actually industry papers. So you're actually doing a project for industry and you get to present to industry. Scary, but really, really enjoyable and really good for your CV as well and getting internships. Then the second project is the lighting design project. That's where you design the lighting system for a office building, which is very interesting, and I've never done something like that before. You use a simulation software called Dialux, and the company Legrand actually came up with that. And that was my favorite project I think I've done so far. It was really cool. And the one I'm doing now in the 2nd semester of 3rd year is a flyback converter, which it's going great, but at the moment I'm soldering a PCB of like 40 components, so kind of annoyed at it, but it's really fun and really, really enjoyable. So that one's going great too. Going on to what I don't like. Obviously, I love electrical. I'm so happy I picked it, but obviously there are things that I don't like, and I thought I would share them with you guys so you can make a good decision on whether electrical is for you or not. It can be very hard. Obviously, every single specialization in engineering is hard, right? Engineering is a hard degree to take. Electrical is not exempt from that. There are some days where I'm like, gosh, this is absolutely impossible, but I always get through it, and it's very rewarding once you get through it. There's a lot of maths. If you didn't like MM1, if you want to try and avoid as much mathematics as possible, do not come to electrical. It's a lot of mathematics covering circuit theory, so circuits are mathematical, right? But if you love maths, come join me. Debugging hardware and code. I'm sure you guys have come across this in 131. When your code isn't working, you want to bash your head against a wall. I've done that a few times. So especially with PCB debugging, which you can see in that picture there, it's very hard to debug something you have soldered. So that's annoying. Projects suck up a lot of time. Yep, that's kind of self-explanatory. Internships are very hard to get in second year. I didn't get one in second year. I have one now, but I didn't have one, so that's always a bit of a bummer. William and Mark's tests and exams. I'm sure you guys have experienced William's tests. They don't get better. They do not get better. But you have other lecturers. William is not the only electrical lecturer, I promise you. There are other ones like Mark who have even worse tests because he taught William. So you can only imagine what I had a test for him last night. I haven't recovered yet. But there are other, they're good, okay? We love William and Mark. They are absolutely fantastic lecturers, and they are probably one of the smartest people I know. Just their tests are absolutely abysmal. But anyway, moving on. There aren't too many girls, I think, in my cohort, and the cohort is very small. There's about 50 people in a cohort, and probably I'd say 10 to 15 of them are girls, but we're all friends, so it's not really a bummer, but just an observation I've made. Now, going on to what I love about electrical. Second year is similar to CompSys and software. So in your second year, I actually believe you take the exact same papers as CompSys, and for software, you take quite a few similar papers as well. So you can really get a feel for the entire, CompSys, software, and electrical specializations. The projects, I'm just going to move this little thing out of the way, okay. The projects, we make really cool stuff. As I said, I designed a speed detection system. I designed a flyback converter. I designed the lighting for an office building. Like, how many people can say they've done that? You know, it's very, very cool and very interesting and very rewarding when you get to present it and say, you know, I made that. I did that. Good for your CV as well. Very hands-on. Yeah, literally, it's very, very hands-on. Physics. Yay! Who here likes magnetism and circuit theory and all that kind of stuff? Yay! I like you, okay. Yeah, it's if you enjoyed physics in high school, you do those in electrical. Exclusive access to labs, use them for study. That's a bit of an insider tip. Level 5 labs, they're great. Lecturers are very dedicated. Yeah, world-renowned for wireless power transfer. If any of you are interested in doing a PhD, potentially, or a master's, or continuing in grad school, we are world-renowned for particularly wireless power transfer. So that's also incredible. Small classes, 50 people cohort roughly. Not too many exams. Yeah, there's a lot of projects. I had 2 exams last semester, I think, so it's quite nice. Part 2 Assistance Center, fantastic. They're so helpful. And a very wide range of fields to go into, more than you think. It's not just, oh, I'm going to build like a circuit, right? There's so many avenues you can go down. I'm going down power systems, which is the generation of power, which is so interesting. So again, it's not just, building a circuit. Okay, this is fun. I know, Oh, have I oh, there we go. Okay, it's all right, I figured it out. Careers and jobs, I've kind of already touched on this. With electrical, you can go into really any side you want to. You can go into the hardware and electronic side. You can go into the firmware and software side if you'd like. Telecommunications, etc., like radio. Research, if you'd like to research, wireless power transfer, etc. Consulting, power systems or avionics. Really, you can go anywhere you want with electrical engineering. It's just so versatile and diverse. Who hires us? You can see a massive range of companies up there. Literally every company is looking for electrical engineers. You will never not have a job. So they're always clamoring for, obviously in New Zealand in particular, there is a shortage of electrical engineers. So you will always find a job, not anywhere, but a lot of places will want electrical engineers. So that's kind of the end of my presentation. Thank you ever so much for listening. I really hope that this has kind of given you a bit more of an insight into what electrical engineering is like and you're not biased by 101 anymore. But if any of you have any questions, I'm actually off to the Stein now. I know I'm a terrible influence. But if any of you have any questions about electrical engineering or about engineering in general, please come find me. I'm quite easy to find. I am a WEN leader, so you can probably ask any of the other WEN leaders if you'd like to ask me any questions. But yeah, thank you ever so much for listening, and I will pass you over to who's presenting next. Civil engineering, yay!
Hello. Hiya. My name's Emma. This is Jessica. We're going to do our presentation together because I study civil.
I study structural.
And they have a lot in common. In second year, you do all the same papers, and there's a lot of overlap, different specializations, but yeah, a lot in common. Should we start? Okay. So, what is civil engineering? It's about the environment and also how we interact with the environment, the built environment, I guess. So it's quite broad. You learn about transport, hydrology, and geotechnical. And so like within transport, you've got pavement design, you've got rail and all the different modes of transport. Hydrology includes like water treatment, wastewater, stormwater, drinking water, even coastal design, and pipes, transporting water, lots there. And geotechnical is, I guess, foundations, your earthworks, it's a broad range, and you learn about all of them sort of throughout the degree. Yeah. A pretty picture. And here's another one. So like for this project, for example, you'd need geotechnical engineers to work out the slopes of the banks and how to stabilize them. Also, a pavement designing engineers to design the pavement. Maybe a hydrology engineer to design the drainage and the stormwater runoff, and yeah, a lot more. Wastewater is obviously it's an important part of civil engineering, water treatment in general, the water that we drink, and then what happens to it afterwards. Yeah.
Hi, I'm Jessica, currently a third-year student studying structural engineering. And so what is structural? As you see, all the buildings around you, all the construction around you. So I do not talk about why I choose to this profession. I think the structure is everywhere around us, and the structure we're standing there for many years. And as we design a good building, we do not see like we are standing there for many years. I still remember the first year I went to the Career Expo, and in there I met the guest speaker from the company construction team. And in there, I was inspired by their holistic and functional design. And yeah, that's turning engineering theory into the functional art. So back in year 3, I chose to become the structural engineer. And yeah. So basically, we learn from the structural engineering, we learn the material design, the structural design, and also the seismic design, just like the earthquake or something else, and beautiful pictures.
Yeah. So like we said, in second year, civil and structural, all the same papers. You get to do a bit of both. Yeah, structural engineering is a new specialization. Our cohort was the first where it split into 2. Yeah. And we were also the first cohort where they consolidated 5 papers into 4, which I'm super grateful for. Don't have to do 5 paper semesters. And yeah. I would just say on relevant first year papers, Engine 121, Chem Mat 140, yes, they are relevant, but one piece of advice I would definitely give is to worry less about focus less on the papers that you take in university. Like they seem like everything now, but when you're making this decision of which specialization, to think about more about where you want to work, what kind of job you want to work in, and not worry too much about the actual papers themselves. Yeah. Oh, sorry. So first semester of part 2, you do a paper on fluid mechanics, you do one on transport, and an introduction to structural, which is the same as what structural students do.
Yes.
Yeah, and then environmental engineering, which is, this paper is all about air pollution, water treatment, air pollution, noise pollution, environmental impact assessments, and then you have a geotechnical paper, and another structural. The papers in italics, by the way, are the ones that all engineering students take. Yeah.
So in the third year, we also need to take in the semester 1, we need to take the Civil 300, which is the geotechnical paper. It's basically focusing on the foundation of the building. And also we take some structuring 300 paper, like the design load and dynamic response of the structure. It's just like we check the standard and analyzing the structure behavior in the different frequency of the earthquake. And also we get some structure design paper, like the timber design, steel design, and also the concrete design. And also we get the elective course. I think civil also do that, the elective one. Yeah. In my memory, the elective course is including the climate change, and the hydraulic, and also the, like, what's your compulsory course? Oh, the transportation. Yeah, and also we got the construction informatics. So basically, it's just the application of the, like, some software using, and you use that artificial intelligence, automation, smart sensor to analyzing the construction and the structures. And also we do the compulsory course, which is the Engine 311. It's a mathematical modeling 3. Yeah.
So a bit more about civil and structural. It's quite a big cohort. I think our year we had almost 300 for the 2 specializations combined, and then about 200 in civil, 100 in structural, something along those lines.
Yeah.
We have a Part 2 assistance centre, super helpful. CISA is a really good students association. They do lots of both social events and also helpful ones like CV checks and that kind of thing. And yeah.
That's right. So we got a lot of internship opportunities. So the first one, the best one is I did the summer research scholarship last summer. So my professor is Cobus, so my focusing is on using the artificial intelligence to analyze if there's anomalation in the pipe. And I think it's pretty fun. It's a great opportunity to help you to get more experiences on knowing more deeper about this industry. And yeah, and also you'll get many opportunities in both New Zealand and also overseas. Yeah.
Yeah. Any questions? Feel free to send us an email or come chat to us afterwards. Yeah.
Perfect. And next up is Hayley from InSci.
Hi, can everyone hear me okay at the back? Yeah, awesome. My name's Hayley. I'm in Part 3 Engineering Science this year, and I named my presentation Engineering Science. What really is it? Because I think that's the question a lot of you guys will have going into choosing your specialisation next year. So what is engineering science? You might see this pretty little diagram if you ask any lecturers about engineering science, but it is the culmination of operations research, data analytics, and computational engineering. So what that kind of looks like in terms of data analytics is doing a lot of statistics and coding and algorithms that can analyze data and teach you something. Operations research, we do a lot of linear programming, which is trying to optimize processes such as transporting goods, and those sorts of things. And then computational engineering, we do things like continuum mechanics, fluid mechanics, and we turn those into computational models, which basically just means we solve it on a computer and try and make sense of it in the real world. So why did I choose engineering science? I enjoyed coding from EngGen 131, and I will say if you really enjoy coding and that's something you love, definitely don't just look to software, because EngSci, I'm doing it almost every other day. I'm using code or writing code, and we get to do it in quite a number of languages. I really enjoyed mathematics from first year. It's quite flexible, so I took a thermofluids paper in second year and a civil paper in second year just to try and get some variety, and you get electives all through, so I've taken a stats elective this year. And then there's a broad scope, so we do papers with biomeng in second year, so we get to do some kind of biomechanical engineering as well. So what does our second year look like? So we have mechanics type papers, and the bio part of that is more just putting it into context. It's basically just the same similar mechanics that you would do in mechanical or mechatronics engineering. You will have to take 211, 233 is a lot of coding, 255 is using linear programming, and we do a bit of statistics and queuing models. So if you want to know how many people are coming into a store and how they're lining up and how they're being served and what that looks like, or people coming into a hospital, that's what we do in those sorts of papers. 204 you have to do. And 263 is really interesting. It's where you start to put whatever you learn in the first semester into projects in a group. So we looked at redesigning Woolworth's transport routing for their delivery trucks and trying to optimize that process. And then we also looked at how much water you could extract from the Onehunga aquifer without disturbing the surrounding environment by calculating the pressure and copper concentrations. And that's something I'll talk about a bit more. Third year has changed slightly. So in the second semester, you have to do, we don't do 363, sorry, we do 344 and 355. So you used to be able to specialise into either operations research or continuum mechanics in third year, but now they keep it general, and the design paper's been moved to fourth year. So you do it in fourth year along with your electives. And the thing you'll notice about this is we do EngSci 314 instead of 311. So along with biomedical engineering, we do a slightly different maths paper, which is a little more stats heavy. But that's the main, we don't do the linear programming again because we learned that in second year, and I know they do the 311 paper, they do that in third year. So this was a day in the life for me. Last year, I had mechanical labs, which were a bit more practical, which was cool. Lectures with Kevin, he's one of the lecturers that teaches a few of the second year courses. And then labs in like Excel, so Excel has an underlying like coding programming language that you can use, and that's actually really flexible and really good to use in industry. And then Python, which is becoming one of the most demanded or in-demand languages to know, so it's really good to be learning that. A day in the life this year is just heaps of coding, learning a new language every other week and starting up some new software, and yeah, it's really exciting and there's heaps of variety, so that's what I would say is a big pull. The not so great bits would be heaps of coding. So we have labs that are worth large portions of our grade in some courses, and also it kind of extends into all your courses. So if we're doing anything mechanical, they'll be like, okay, but code it up if we have a project instead of just solving it by working out. You kind of get split up from your cohort a little bit in second semester when everyone's taking electives, and we also do all of the most of the second year first sem papers with BME, so you kind of get split up from your friends a little bit. And then also you always have to explain what EngSci is to people, so that can get tiring, but it's all good. So here's some of the project work we did. I think this is the best way to explain what engineering science actually looks like. So all of the coding, you can see the plot in the bottom corner, that's all done in Python. And then yeah, we kind of had to take a problem and model it conceptually, do all the physics behind it, so that's where all the math comes in, and then code it up and solve it numerically. So when you guys are doing your ODEs and PDEs, that's something we try to convert basically to start writing our own solvers in code, and you become industry ready in your third year to go out and write ODE solvers for companies. I did put a video in, but I knew it might not work. This is of a short clip of a presentation that we had last year for our project work.
Plotted here, we've got the bottom line represents an extraction rate of 1 million litres per day, and the top line represents 14 million litres per day. And we've plotted the copper concentrations for each of these. So as you can see, in that top region, we have very steep linearly increasing trends, and in the bottom region, we have more gradually linearly increasing trends and even some parabolic decreases.
So projects like these are really great because when you go to try and get your internships, you can talk about how you've worked in a group and that it has a real world application. So yeah, that was good. And yeah, so there are so many career opportunities within engineering science because it's such a varied degree and you can really take it in any direction. You can work for a wide range of companies. I've just put some where I know Eng students have gone on to work or have interned at. Last year I interned at PowerCo in their asset management and I did a lot of data work for them, and this year I'm interning with Watercare and more of a project management role. So there really are a heap of different avenues you can go in. I also know a lot of people are getting kind of quant trading jobs in Australia, etc., when they graduate. So it is in quite high demand in the business world as well to have the skills that we develop in Eng. But really, my view is that because you do such a variety of things, you can go and work anywhere you want to and apply those skills. The culture, so we have really quite small class sizes, so you do get to know everyone really well and get to talk to your lecturers. You also get to interact with other cohorts. It depends on the electives you take, and of course you interact with BME. We have quite an academically driven cohort, so we lean on each other a lot. We don't have a part 1 or part 2 assistance centre, so you just have to get your friends to help you with stuff. We have a really active and great student club, which is BISA, and that's with the biomedical and engineering science students, and we do internship evenings, and we also have a range of sponsors which we try to connect students with. And then, of course, we have the Inside trip in second year where you go down to Topor, and we got to see a geothermal power plant, and we looked at a number of different companies, and it also was just a great bonding experience for our cohort. So yeah, if you have any questions, feel free to ask me afterwards. But yeah, thank you.
Awesome. And next we have Izzy from Biomedical.
All right. Can everyone hear me? Is that all good? I'm a little bit taller than Hayley, so I might move that up. All right. So hi guys. I'm Izzy. I am part 3 in biomedical engineering this year. I'm also doing a conjoint with commerce. We're one of the smaller cohorts. This photo was actually taken at the start of last year. So since then, we have lost a few people to Eng and overseas exchanges, and we're now down to 20 people in my class. But I thought I'd start off with talking a little bit about what biomedical engineering actually is. So we do a lot of learning about mathematically modelling biological processes like enzyme reactions and the stresses and strains of body tissue, as well as coding normal maths, as you can see in all my B-reels up there. So a few of our papers are project-based, so we learn a lot about making measurements and processing them to interpret what is going on in your body when you're breathing or when you're sick. With these project-based papers, we also design and construct electrical circuits to help, but don't worry, it's not as hard as actual electrical engineering. We also learn about the physical properties of tissues like bones and muscles, as well as some fluid mechanics to look at blood flow. It's super interesting to learn about the maths, which describes what's happening in your body every day. So to make up the biomedical part of our degree, we take one biosci or medsci paper each semester. These papers are all about how your body systems work to keep you alive. They are super interesting, but definitely content heavy. Part of what makes them so interesting is there a link to what we're learning in the engineering papers at the same time? So in one of our classes last semester, we were learning about the stress and strains of heart muscles when your heart beats. And in the MedSci paper, we were learning about the process of how it actually beats and the electrical activity involved. My favourite part of these papers are the labs. We have dissected rats, cow's hearts, chicken legs, done an analysis of cow blood composition, and we even made these models of fetuses. When you get to third year, you will discover the joys of writing lab reports. I think my last one was 20 pages long, but there are only 3 big ones that you have to do. Thought I'd give you a rundown of some of the papers that we do. We've got Biomeng 221 and 321, which are all about modelling the physical properties of biological tissues. And then Biomeng 241 and 341 are our project papers. Those are where we do group projects over the course of the semester and learn everything about sensors and signal measuring and processing. Biomeng 261 has been the favourite amongst my year group. We learned all about modelling enzyme reactions, but we also covered lab processes and even did a module on ethics and the ethics of research and experiments, which was pretty cool. The MedSci and BioSci papers I just talked about, and although we've got EngSci 233 and 331, they are essentially 131 on crack, but do not let the coding put you off. There are coding labs due every few weeks, but these are totally manageable even if you've never coded before uni. If you go to the lab sessions and ask for help when you need it, all the TAs and lecturers are really nice. In third year, you also get an elective. The most popular one this year is the exercise science one, but you can also do papers from mechanical, EngSci, MedSci, and other ones too. Because you get taught such a wide range of content, the career opportunities as a biomedical engineer are really wide. So up there you've got the classic Fisher and Paykel Healthcare, who work on a ton of projects around heating and humidifying air for patients to help them breathe, or even to inflate their abdomens during surgery so the surgeons can see what they're doing. There's also Aroa Biosurgery, who are doing pretty cool stuff with using sheep stomach tissue cells for wound healing. Douglas Pharmaceuticals and the Liggins Institute are more on the medicine side, but again, you have this, they're good opportunities that you have the skills for. And then because you do the computational techniques with EngSci as well, you open yourself up to places like Deloitte and Oricon, Auckland Council, Rocket Lab, and the software firm SwipeDon. The ABI up at the top of Simon Street has a few biomedical engineering firms coming out of it. So that's the iMeasureU one, which looks at monitoring athletes as they train and compete to gain insights on how they move, especially after injury. There are also lots of prosthetic companies I have not included. People tend to see BME as closing yourself off from other options, but I don't really think this is the case. However, if you do want to get into this type of work, BME isn't your only option. Mechanical, mechatronics, electrical, and software also give you the skills that you need. The biomedical cohort is quite small. There are only 20 of us this semester, most of which are girls. This is great as we all know each other and have worked together before, which is really fun. It also means the lecturers and teachers are more than happy to answer your questions during labs and tutorials. We have a few papers with the EngSci cohort though, so it's never too small, and we get to know them and make the most of their coding superpowers. One of the highlights of being in BME is probably the field trip in second year, which Hayley just mentioned. We went down to Taupo too. We talked with a bunch of engineering firms, both from Auckland and Taupo, but mainly we just went sightseeing and explored Taupo town, which was really fun. The BISA Student Association also puts on barbecues every semester up at the ABI and other great events around developing skills for internship, hunting, and also they run a few pub quizzes too. Oh, whoops. Sorry. There's my email up there if you've got any questions, but thank you and hope to see a few of you next year.
Awesome. And next up we have Serena and Sophia from Mechatronics.
Hey, all right. So Sophia and I are here to talk about mechatronics engineering. I'll just quickly introduce myself. So I'm Serena. I'm a part 2 mechatronics. Yay. I'm on the WEN outreach team. As you can see here we can do lots of workshops. If you ever want to be a WEN volunteer, come on and sign up. It's good fun. I'm also on the Mecha exec. I'm obsessed with space, anything aerospace related. If you like that stuff, come talk to me. It'd be great. Yeah, what else? Why did I choose mechatronics? Because I'm indecisive, and mechatronics covers a lot of things, and we will go into that shortly.
Hi, yeah, I'm Sophia. I'm also part 2 mechatronics. A little bit about myself. I am exec on RoboGals. You should come volunteer next year. We're finished up workshops for this year. Shameless plug. But I'm also on WEN Equity. And I also work as a production engineering intern at Halter, part-time. And yeah, that's pretty much about me. Why I chose mechatronics, also indecisive, but I originally wanted to do civil, which is quite a change. But main reason why is probably after doing first year and realizing I really liked coding, and you get to do some software and programming in mechatronics, and I also still wanted to sort of, I guess, access to like mechanical and that kind of side of things, and I realized I actually really enjoy doing that stuff, having done over a semester of mechatronics so far, so I definitely feel like I made the right choice, so yeah.
All right, we'll move into what mechatronics actually is. Yeah, so this is the sort of thing you want to say in your interviews when they ask you, why did you choose mechatronics? It's a multidisciplinary specialization consisting of mechanical, electrical, software, and computer systems. But that's pretty much what it is. It is just a big mush of everything, which is kind of great in a way because you can sort of do a bit of everything, but also if you want to sort of specialize more into one particularly, you can do that as well. And as I said, we're both very indecisive. It's good if you're not entirely sure what you want to do, because you can start off going into mechatronics, and then as you choose your electives and go into sort of the career path that you want, you can specialize further that way. Yeah. Right, the part 2 courses. We get one elective, and we get to choose from one elective. It is wonderful. It's a good time. Sophia, would you like to elaborate?
Yeah, so that elective is actually, it really is an elective because if you're a conjoint student, you actually don't have to take that one. So I'm a design conjoint student. I should have said that earlier. So I didn't actually take that course, but Serena did, so she can talk a bit more about that one. But other than that, you pretty much take all the courses here. And there is an option to skip Engine 303 if you're, depending on your conjoint as well, but I can talk a bit about that as well. But other than that, you're pretty much taking all the courses if you are interested in doing a conjoint or if you already are in one. Yep.
And if you're not a conjoint student like me, you have 8 compulsory papers. Yay! One elective. That one lovely elective, yep. Yeah, so a quick breakdown. We won't go too much into this because our lovely friend Alicia over here in mechanical is going to talk a bit more about these courses. Yeah, I don't know, it's relatively self-explanatory, eh? Yeah, I suppose 235 is sort of another design paper. It's like 115 on steroids. I think it's cooler though. It's really fun. You get to be a bit more creative and express that side of yourself. 242 is, yeah, you get mechanics of materials. Combine those 2 papers, that's what you get. 201 is a bit different to what you do in first year. It's more about robots. You actually get to be more hands-on and you get to code and see robots, see? Yeah. And get your robot to do stuff, which we'll talk more about in the next slide. Engine 204, everyone does it, won't talk about that. Thermofluids and dynamics and software design as well. Software design is the one paper that's different to mechanical in second year. So we take 7 of the 8 same courses. So it differs a lot more in third and fourth year, but in second year it's mostly the same. And in software design, we get to do object-oriented programming, or OOP. Lots of oops, and yeah, in this course. Yeah, and so we code that in C++, and yeah, the projects are killing me at the moment, but it's a good time, yeah. And those are 3 electives that you sometimes see your Eng-Sci friends come in, and they just kind of pop in the lecture, and then they run out, and you're like, they're not mechanical or mechatronics, all right. Yeah, so we have sort of 3 dominant projects, and sort of particularly in semester 1, because we're only part 2, so we only have so much to talk about right now. But the VEX project is the one that's covered in 201, and that's the one where you get to code this beautiful robot over here. It's also very janky and doesn't do what you tell it to, which is quite annoying. So it's a big trial and error thing as well. You get to hard code those values in. But yeah, and so you essentially code it to do a circuit that's on the mats on the ground, and you get to learn about P and PI controllers. And then in 235, which is the design paper, we do window washer and Warman. Warman's the one you'll do first, and this is one where it's actually a global competition that you get to sort of compete in if you want to, but you'll design like a conceptual system or robot to do a specified project. So this year we had one where you had to pick up a payload, you have to traverse across a wire, and then drop.
And then traverse back.
Drop it off, deposit it at a very specific location, and then get back to the start again. Which, yeah, if you're doing it conceptually, it doesn't need to actually work, so you get some really interesting, funky designs there. But if you're building it in person, which some of us are, you have to be a bit more realistic. Do you want to talk about window washer?
Sure. Yeah, window washer is very mechanical focused. You're looking through a lot of catalogs to pick components to basically carry out what's in the brief. And I'll be honest, I've forgotten most of it. It's been a few months. I've blocked it out of memory. But basically, you do create a CAD render of it at the end. But a lot of it is combined with Mech-Eng 242, which is the mechanics and materials paper, which I quite enjoyed. It was cool seeing the crossover between the two papers. And I also enjoyed kind of using MATLAB. So they don't tell you to do this, but you can if you want, like kind of using your own knowledge. And I sort of used MATLAB to help code up a lot of the calculations, which was quite helpful because it's quite an iterative process to do that project, and just something to keep in mind if you do take it. But yeah, that was actually really enjoyable. I quite enjoyed that for some reason. Yeah.
All right, cool. We'll move into part 3 courses. What's an elective? We don't know yet. It's, yeah, something we don't get to experience just yet. But the great thing is if you come into mechatronics, often you are indecisive, which means you don't need to make decisions. It's great. Yeah. We won't go too much into the part 3 and 4 courses because that's probably something you can look into yourself as well. Although, oh, do you want to go ahead?
Yeah, so one thing to know is a lot of what you do in part 2 in mechatronics is mechanical focus, with the exception of that one software paper. You don't really do any electrical stuff until part 3, which is why we can't talk too much about that. But as you can see, there is a lot of software and electrical stuff in part 3, and I've heard that a lot of the projects are more interesting. So if you find part 2 hard, a lot of people talk about the part 2 blues. Stick it out for part 3. Apparently it gets better. Yeah. Yeah, so some of the projects that I've gathered from current part 3 students who actually know more than me. So just bring up my notes here. So one of them, this one and this one are from Mech-Eng 306, which this was sort of focused on, bring up my notes, looking at creating systems such as like laser cutter, 3D printer, CNC machines, using sort of an XY planar work table to draw a rectangle of specified horizontal width and vertical length, and a circle of specified diameter. So basically just creating a system that can actually draw something. So it's really a combination of electrical, mechanical control systems, which is quite interesting if you're into that kind of thing. That is what mechatronics is really about. And then the last photo there is from Mech-Eng 325, which was apparently introduced students to the use of commercial CFD package, ANSYS, CFX, I wish I knew what that was, I'm sorry. Looking to solve an internal pipe flow problem, examining the results, comparing them with published data. So that was an example of a student's work from that.
It's really fun watching the part 3s complain about drawing a square and a circle because it seems like a really simple task, but it's not. All right, part 4 courses. Yeah, this is where the electives come in. We now know what an elective is. Yeah, so you get 1 elective in semester 1 and 2 in semester 2. I don't know much about these courses, but apparently aerohydrodynamics, really cool. Biomechatronics systems, also really cool. Do you know much about them? I don't.
A little bit.
Let's go.
I've also heard from people who've taken like acoustics, multivariable control systems, and yeah, biomechatronics, and also I believe it's smart manufacturing, where you get to look at using additive processes like 3D printing, and you go very into depth into how those work. So if you're interested in those sort of things, that's also something you can explore with electives. As you can see here, you pick 1 elective in semester 1 and 2 electives in semester 2. Your part 4 project is like its own paper in a sense, and that carries out through the entire year. And then you also have the core courses, Mech-Eng 705, 706, and of course 403 in semester 2. But yeah, basically, I definitely recommend going and talking to some part 4s. Obviously, we can't give you too much insight onto these, but if you're curious about these electives, just go seek out part 4s and ask them what they're about.
And that leads us into the next thing, which is Part 4 projects. Go find those Part 4s and ask them what they're doing, because that's a good time. Do you know?
You can watch their faces fall. So, for example, a lot of people in mechatronics do a lot of stuff with drones. So if you're quite interested in those, drones is a pretty big topic for Part 4 projects for mechatronics, but also robotic systems, of course. So here's some examples of Part 4 projects that people are currently undergoing. So a lot to do with robotics and, again, drones, so programming, but also getting to build. So again, that combination of mechanical and electrical and control systems and how those intertwine.
And next up, we have internships and careers. So being in mechatronics, being very broad, we can apply for a lot of things. As you said, yeah, mech, software, electrical composites, we're going to steal all of their internship spots. It's great. But I guess the downside to that is we can apply for a lot more things. But the thing is, if you are going for a specifically like mechanical role and you are up against a mechanical student, they're more likely to take the mechanical student because they're specialized. But that doesn't mean that you can't get that, because you can apply for a lot more things. And so the odds end up evening out. So you're not actually overall at a disadvantage. Yeah, but you can, like I said, if you sort of really like electrical or software, you can apply specifically for those roles while being in mechatronics, which is super, super cool. Yeah, you got to write a lot of cover letters though, so have fun writing those. But that's everyone, something everybody has to, so yeah, I see lots of nodding heads over there. Good time. Yeah, so some of the ones up there, yeah. So if you like rockets, I love rockets. Rockets are so cool. Yeah, Rocket Lab, and then also engineering consulting as well. So we have Becker. You can also go for the Big Four if that's something you're interested in. And then all of these other companies, whether they're related to mechanical, electronics, or software. Just going to do a quick shameless plug here. We do have a couple of the bloggers here, myself included. If you want to know specifically more about like 1 or 2 specializations, and you sort of want to read a day in the life of what the things they do and about the courses, yeah, there's a QR there. You can also just Google Part 2 blog into Google, and it'll probably come up. And yeah, and so you can sort of read their posts about their specs. And finally, another shameless plug. If you want to know more specifically about mechanical and mechatronics, Maker is holding an event next Friday, which talks more into detail about all of these courses and the projects that we get to do. We know you're free because we picked a time which you're free. So come along if you're interested. And there is snacks as well, if that's something you're also interested in. So yeah, come along. Cool. All right, thank you.
And next up, we have Inuri from Computer Systems.
Cool. Hi, everyone. Can you guys hear me well? Cool. So my name is Inuri, and I'm a Part 3 Computer Systems Engineering student. So before we go, have a deep dive into what a life as a computer system engineer looks like, can I have a show of hands as to who's considering computer systems? Wow. Not many people, but I see 1 or 2. Let's see if I can change your mind after. Cool. So what is computer systems? I think Chantal did talk a bit about it. So it's an integration between software and hardware. So you do a bit of electrical and a bit of firmware, like software side of stuff. So it's a continuation of the digital section of Elect-Eng 101, as well as the analog side of Elect-Eng 101. And then for the hardware side, I think you guys do a bit of microcontroller programming. I don't know if you do it this year, but I remember doing some when I was in first year. So you do still do microcontrollers, but every semester a new microcontroller gets added, so you can have a go at different types of microcontrollers. And yeah, you learn software in loads of different languages, C, Java, Python, JavaScript, if you choose the more software side. So why did I choose computer systems? So I came into engineering thinking I want to do mechanical or mechatronics, but yeah, hasn't kind of changed my mind. So I'm doing electrical and software conjoined. So that's why I'm doing computer systems. So I really enjoyed the electrical side, not so much electrical, but software side mainly. And I knew that I didn't want to be stuck in front of a computer doing software all day. So that's one of the reasons I chose computer system, because you get to have a go at the hardware and the software side. And you do a lot of projects, yeah, it's another thing. Cool. So a day in the life of a computer system engineering student, it's mainly attending lectures, labs, tutorials, office hours, yeah, the usual stuff. And you'll be doing a lot of lab work. So 3/4 of your time would be in the labs, but it mainly depends on your time management and then assignments and all those stuff. What else? Okay, so a bit about projects. This is the project that we're doing with electrical students. So that's the smart energy monitor that Chantal talked about. So unfortunately, we didn't actually get to build it because we were under lockdown. So this is a simulation of the PCB that we designed, and that's the LT Spice model that we had to design before that to do all the testing. And in part 3, you get to build Flappy Bird. Isn't that cool? So this board there, it's called the FPGA board. So you basically hardware program. So you don't have to deal with electrical components in that. You just have to write the hardware program. So you get all the graphics over there. And then on the other side, you have, this is a part 3 project that I'm working on right now. So that's an incomplete PCB. So I'm working on it currently. So you have to program that robot to follow a pattern. And there are light sensors on the PCB, so it has to detect whether it's under a white light or a backlight to figure out its path. So that's that you do in semester 2, and the other one you do in semester 1. And these are both compulsory papers, so you have to take them. Okay, so the next 3 years of your life, if you choose computer systems, I guess. So in part 2, as you can see, in semester 1, you have 4 papers that are compulsory for everyone. So you have a bit of electrical as well as software. So there's object-oriented programming. I think mechatronics had OOP. Oops, I guess. So yeah, we do it in Java. And it's a really important paper because you learn a lot of fundamentals for software. And then ElectEng 291. William teaches it. Well, his tests are the same. But he's a really cool lecturer. Like, he knows so much, and you can learn a lot from him. So that's the electrical part. And then you learn the fundamentals of computer systems, like registers and all those stuff that's inside a computer. That's from ComSys 201. And then NSci 211, it's the continuation from 111. And in semester 2, you take ComSys 209. That's the same as ElectEng 209. That's the design paper. So you learn the fundamentals of design in that paper. What else? Oh, 292. So that's electronics. That's what Mark teaches. So that's William's teacher. And in there, you learn a lot of filters and all those transistors, op-amps. They might not make sense to you, but if you do ComSys, they'll make sense to you once you get to that point. And then you have 204, that's the professional skills and communication. That's the group work project that you have to do. And then for electives for that course, you have electromagnetics, then software quality assurance, and data structures and algorithm. So I chose the 283, the software paper. And in that, you basically learn about how to code well, like how to follow good code principles, so someone else who hasn't been there when you were coding it can look over it and quite easily understand what you were doing. And then you have data structures and algorithm. That's another software paper that you can take in part 2. And then part 3, we have ComSys 305. That's the Flappy Bird paper that you have to do. And then you have 303. That's the group work project. Then NSci 313. That's the maths paper. But it's different to the maths paper that other people do. It's more electrical maths based because it was meant for the electrical software and computer department. And then you can choose an elective from 2 options. There's design software practice. I didn't take that, but my friends who took it said they had to make an app using Android Studio. I think they had to make a food app. And then I chose computer-human interaction. So that's, if you want to learn about user experience, UX design, that's a really good paper to take. So you would do a bit of web coding using HTML, CSS, and JavaScript. So that's cool. And then in semester 2, you have ComSys 301. That's the design paper. So that is the paper where you have to build the robot that I showed earlier. And then there are 3 elective options that you can choose from. So there's applied electronics. That's the continuation from 292, electronics in part 2. And then there's signals and systems. Then there's control systems. I think that's quite similar to what mechatronics students take in year 3. And then there's software architecture, if you are really into software, as well as network and security. And then there's microcomputers and embedded systems. So in that course, we have to build a pacemaker. So not actually build one. We have to implement the logic of a pacemaker. And then in computer architecture, you learn all about assembly code and computer memory and how you can program well enough so that you efficiently use all the memory available for you. And then there's artificial intelligence and machine learning. So if you are really into AI and machine learning, that's a really good paper to take. So if you guys are interested in electronics, hardware, software coding, and all those different stuff, and I forgot to include one, if you like designing PCBs, do ComSys or electrical. And there are lots of different companies that you can get internships and make a career out of. This is just some of them. So Rocket Lab, Apple, Fisher & Paykel Healthcare, Datamass, Xero. So if you do computer systems, and depending on what electives you take, you can go into the electrical side or the software side. So there's the option for you to specialize in one without actually specializing in that. Well, that's it. Now, can I have a show of hands who wants to do computer systems? Well, I guess I didn't change many people's minds. Yeah, thank you.
And next we have Alicia from Mechanical.
Hi guys, can you all hear me okay? Yes? Okay, so I'm Alicia, I'm part 2 mechanical. So a bit about me, I picked it because like the mechatronics students, I wasn't really sure what I wanted to do, and it's very broad. Please keep in mind my experience has been exactly the same as them pretty much so far, but I will touch on the one course difference that we've had. So a lot of people think that mechanical engineering is just maths and physics, and I'm not going to lie to you, it is a lot, but there's also the design aspect of it, which is very heavy. So if you liked 115, it's great. Also material science, we're very involved in manufacturing, and because it's so broad, there's a very wide range of industries you can get into job-wise. So the great things about mechanical is very hands-on, which is another reason why I picked it. Like if you enjoy learning how things work, it's great. You get to be creative a lot. Like if you enjoyed 115, you'll really enjoy it. And you get to improve your teamwork, which you may not enjoy so much, but it's really important later on, especially in the workplace. And yeah, the range of industries you can get into, which I will touch on later on. So relevant courses, so like I said, 115, if you like designing, CAD. We have 2 courses, so we have 235 and 236, which are both relevant in second year. They're like follow-ons from it. And then ChemMat, we do a lot of analysing materials and when they reach failure. And then also Engine 121, which I know is going to sell it for you all. We love HASM. We do dynamics. So in second year, dynamics becomes an entire course. I will say I did struggle with dynamics in first year. I think it's a lot coming from school into dynamics, but by second year it's a lot easier, I would say. I found it that way. So projects. So we do the same as mechatronics, but the one difference we have is the 236 project. So we have the Warman, which is the middle one, and the window washer. But in second semester, which we're doing right now, we have a 236 project, which instead of being split into 2 projects, we have just one, and we work on a 3-wheeled vehicle. So it really helps develop your teamwork. So someone will get given the clutch, someone gets given the brakes. I'm on the chassis and suspension, and you work together. It's really important that you kind of communicate with your teammates to make sure everything will fit together. So hopefully it will. All right. So courses. So first semester, so 242 is basically a bit of 121, and yeah, so it's basically materials mixed with physics, so analysing when things fail. 201 is actually introduction to mechatronics. So we do a mechatronics-based paper, which I actually really enjoyed. So that was using the VEX robots. 235, so that's an advanced version of 115. So there you design the Warman project and the window washer, and then inside 211, which is the second year math paper, all of you take it. Second semester, so at the moment we're doing 222, which is dynamics, 211, which is thermofluids, so, and then 236 is a follow-on for 235, and 204, which everyone takes. And then part 3, again, no electives, unfortunately, but we have 4 of the same courses as mechatronics, and then 4 kind of branch off and are different. Part 4, you get to pick 4 electives this year, so you get to kind of specialise or go down the path that you enjoy a bit more. So I would recommend also with your internships, use that as kind of an opportunity to figure out what you enjoy doing, especially so if you, say you went into water care in your second year and you really enjoyed it, you can use that to kind of influence what you pick in your in your 4th year. And like I said before, there is a huge range of industries that you can go into. So anything, like, I've been told that there's actually a lot of mechanical engineers, even in fashion design. Like, it's crazy. Finance, also, water care. Yeah, it's a huge range. And I think the work you do in CAD definitely makes you very valuable in the industry. So it's great if you enjoy hands-on concepts, and it takes a lot of visualizing and a lot of design. It really helps develop teamwork skills. So it can make it very difficult if you can't work well in a team. It really helps you develop those skills. It's employable in a wide range of industries. Unfortunately, there's no electives till 4th year. There is not a lot of girls at all in mechanical. I think, I can't say this year, but I know last year there was 20 out of 120, which is quite low. So, if anyone wants to come help represent. And it's a very project-based course. So I think more of your grades as you progress through it will be based off projects and less will be based off exams and tests and stuff like that, which is something I really enjoy. Thank you for listening. If you have any questions, feel free to email me or talk later. All good.
Sweet. And next we have Leah and Amisha from software. Whoa, it's so scary.
Hi guys, I'm Leah.
I'm Amisha.
And we're going to talk a little bit about software engineering today.
So we're both Part 2 software engineering students. So just before why software, just a little bit about what software actually is. So, I mean, it's kind of self-explanatory, I guess, but like, I guess just think of it not just like us sitting behind a computer and writing code all day, although it's like a lot of what we do. But like, I guess it's just you learn how to write code like well and like design for clients and stuff and keep it in mind because like obviously they can say like one thing and then like you code it up and it's absolutely nothing close to what they wanted. And basically just keeping in mind things like time efficiency and stuff with your code. So it's not just like writing code, like plugging it into like Code Runner and being like, oh yeah, all your tests passed. Like it's not, that's just not what it is. So it's a lot more than that. So just like why we decided to choose software, I guess Leah can
Yeah, just before, I just wanted to add to that. We do a lot of coding and most people like think that software is like pretty antisocial, but it's actually very social. It's very people focused. So yeah, should I go? Yeah. Okay. So for me, I did a little bit of high school coding. So I did like Python and HTML, CSS beforehand. So software is already kind of on my radar, but I was still undecided, which is why I chose engineering. But I was considering doing mechatronics, and I realized I did not like the mechanical part of it, the one-to-one, all of that stuff. So I was like, okay, maybe comps. And then I was like, oh, 101 exam. So then I was like, okay, I'll do software. Yeah.
Okay, so I have a little bit of a different background to Leah. I never did like any coding until literally like 131 last year. And basically I found out, like this is a bit weird, but I found out that I really like debugging my code. Maybe not like a universal like thing, but I really enjoyed that and it became like my favorite course of the year. So I guess that's kind of why I decided to go into software. But like, I guess 131 isn't like a prime example of what we do in software, but it's a pretty good indicator. So yeah. Okay, I guess I'm talking about this. So in Part 2, Semester 1, this is like all the courses that you'll be doing. So 3 of them are compulsory courses. So that's 211, which like everyone does. And then you have ComSys 201, which is done by electrical, computer systems, and software. So that's just like more of like a hardware side. So it's like the second half of 101 vibes, basically. And you do a little bit of like learning about a microcontroller. And then SoftEng 281, which is basically object-oriented programming. Oop, you know, throwback. So we do that in Java. So we learn a lot of like programming fundamentals in SoftEng 281, which is like really beneficial for just like all your courses later on. And then you have 2 electives to choose from. So you can go for an electrical one, which is 291, or the software one, software engineering theory, which is what me and Leah both did. So that one is like discrete maths and like doing mathematical proofs, and it doesn't sound very fun. It was an interesting experience. It was quite different to like any other maths that you might have done before. So it was like a little bit of a learning curve, but it taught you a lot of good fundamentals that you would need in second semester onwards.
Yeah, so in second semester is kind of where we branch off from the rest of ECSC cohort. So 204, everyone does that, a lot of group work. In SoftEng 206, a little bit kind of like a continuation with the OOP paper that we did in Sem 1. So we do Java and we do some really cool projects, or just one project. And we work in a group, which is very interesting if you've never coded in a group before. So we get to learn about that, merge conflicts, Git, all that stuff. And then we also do SoftEng 283. So this one is compulsory for us. It's quality assurance. So like Inuri has mentioned, making sure you code efficiently and like well, and like documentations. It's very client facing, making sure you know what the client wants and stuff like that. And then you also get to choose one elective. So there's some electrical papers there, and there's also SoftEng 284, which is what I chose and what Amisha chose as well. And it's kind of continuation with 282. It's not an easy paper, but it is really helpful if you're like applying to internships and they ask you about that stuff. So at least like, you know, yeah, we got a cool lecturer for that one as well. Sweet.
Do you want to talk about this one?
Yeah, sure. So this is one of the projects that we did in Sem 1 last semester. An assignment, sorry. So basically what we had to do was we had to make like a burger shop, like a point
Like
of
an ordering system?
ordering system, yeah. So basically, as you can see on the screen there, you get to choose like your burger, your order, remove stuff from your cart, show your cart, stuff like that. So this was done in Java, stuff. Yeah.
Yep. So this is from this semester, so in SoftEng 206. So this is our software engineering design. So basically we had to program a game, and it's called Quick Draw. So basically it's like you get a word and then you draw that whatever it is. So like you can watch as I fail to draw a boomerang. I just could not do it. So basically you draw that, and then there's an AI, like machine learning model, and basically those are like the predictions on the screen. So you have to get your drawing to be like in the top 3 predictions that the AI makes. So basically you just have to try and like draw like how the AI would guess your thing to look like. Yeah, basically. So this is just the alpha version. So everyone had to do like their own one, and then we're going into a beta version soon. So we're in groups for that one, and you do coding as a group, and we're adding a lot more features and styling to make it like appeal to like an audience, like children or like or, like elderly and stuff. So yeah, I made it. Yeah, so this has been like the first time we got to code, and it's not just like output to console and stuff, like it's actually something we made that like people can interact with. So it was a really good experience.
Yeah, it was done in Java as well.
Oh, yeah. Yeah. Cool. Yeah. I think it's almost done. Yeah. Okay.
Cool. So this is just like a quick overview of what's to come in the next few years after that. Obviously, we're just part 2, so we can't say too much about it. But as you can see, there's some like database stuff. There's a continuation to the design paper, some software architecture, so like back-endy stuff. And you get to choose a lot of electives. There are a couple of software ones, but you can also choose from different departments, such as computer systems, electrical, and even some from computer science. And honestly, if you can find like a paper that you really, really want to do, you can like reach out to Nasser, who's like the software head, and I'm pretty sure he can like sort it out for you. But if you want to know more, keep an eye out for the ECSC electives night. I think it should be coming up soon, but yeah, keep an eye out for that. It was really helpful.
Yeah, so like if you just want to like find out more about any of the part 2, 3, or 4 courses, there's a little QR code that you can scan there. Okay, is that it?
Yeah, I think so.
Oh yeah. So yeah, you can just contact us anytime if you have any questions or anything about software, or just like, I don't know, just want to talk.
Yeah. If you're worried about like the software GPA requirements, but you're like really keen for software, we would still recommend to put it as your number 1. Don't count like yourself out because of that. And yeah, come find us if you have questions. Yeah, thanks guys.
And lastly, we have Cassie from ChemMat. Sorry, and Mia.
Hi, can you guys hear us at the back? Yeah? Okay, so we're from ChemMat. I feel like it's quite different from the others.
Very.
Very. So if you like chemistry.
And really hate coding.
Yeah.
ChemMat's
and math. How do I go to the next one?
Here we go.
Okay, this is about me. So I'm doing engineering. We're both part 2 in ChemMat. And actually, can I go back? That's our, if you see it, I'll picture, that's our favourite lecture theatre. Almost all of our lectures this year at least have been in this one lecture theatre. What day is it?
Not even in the engineering building. It's really weird.
Technically the architecture building. We have like 3 in a row in that lecture on one day. But anyway, okay, why did I choose chem mat? So I really like chemistry. In high school, I actually really hated chemistry. But then before I did engineering, I did a year of physics and did a couple chemistry papers, like university level there, and found out I actually do like it. And high school chemistry is not a good representation. I was also really not very good at the math. I really don't like calculus, so I think chem mat was a good choice for me. You can sort of get away from it quite a bit, and I really liked Engine 140 and chem mat 121. What about you?
Yeah, so I really liked chemistry in high school, completely different. And I kind of knew when I came into engineering that I wanted to do chem mat because of the whole chemical side. I really wanted to go into like the nuclear side, which is like New Zealand. Why? But yeah, and I thought that would be a great stepping stone. And to be honest, I didn't really know what chem mat is, but yeah, my views have changed on like where I want to go. But it's so good because chem mat is so broad. You can go in so many different industries. So yeah.
Yeah, I didn't even consider chem mat until like semester 2 of part 1.
Yeah, 121 was really good.
Yeah, okay. Did it turn out how we expected? I think yes. What do you think?
Yeah, it is a lot more than just like chem mat
Chemistry.
121.
Yeah.
And chemistry. Like you
Yeah.
only have one paper in second semester, which is actually chemistry. And then one that is really the materials side. It's a lot of like the first section of 140 with all like the material and energy balances, and you get to love drawing block flow diagrams.
Yeah, lots of diagrams. So it's like a lot of like process engineering is one side of it, and then Auckland Uni also has the materials side, which is pretty cool, honestly. Okay, this is the courses. You can see the highlighted ones and the materials ones. So it's like a fair amount of that. There was only one course. Not a lot. But I think you can, for electives, you can choose more materials ones. In first year, there are no, or part 2, I guess, there are no electives.
Yeah.
So easy decision there, I guess.
Yeah.
And then part 3, how many electives do we have in part 3? One in part 3. How many?
And then 2 in part 4.
2 in part 4. Not a lot of electives, but yeah. Okay, what do we actually do? Yeah, there's a fair amount of lab work. I feel like we have less projects than the other.
Yeah, we don't really have a lot of projects, but because of the labs, you get to really relive your kindergarten days and add baking soda to vinegar and make blow up a balloon.
Blow up a balloon, that's pretty cool. I think one good one, we made a conducting polymer. So it's like we grew it in a polymer that is conductive. That was a pretty cool one. And then group projects, we've got one pretty big group project this semester that we're doing. And it's like looking at, so each group has like 5 people in it, and it's looking at different like chemical process industries. So my group's doing like sugar refining.
Yeah, I'm doing winemaking.
That's a pretty good one, winemaking. And yeah, I think the courses are probably a bit more content heavy and like remembering things, like memorizing, especially the materials stuff.
Yeah.
And then day in the life. So we've got classes start at 1 p.m, which is pretty good.
So
Lots
good.
of sleep-ins. I don't know if it'll be the same next year, but pretty good. On the downside of that is they are all consecutive, like in a row.
In a row, yeah.
But
like on a Tuesday, we currently have 4 hours,
4 hours
straight
in a row
with lectures, and then on a Wednesday, 3 in a row, all in the same class. So,
but you don't have to start till like the middle of the day, which is pretty good. And not too many tutorials or labs as well, which is pretty good. And yeah, so this is some pictures of the labs. You can see that one with the orange and white thing. That's one we're doing at the moment. It's like Juice Sunday.
Yeah, so that one there, we basically run water through a whole bunch of different pipes and then measure like the head loss for it, and like, this is all fluid mechanics kind of stuff.
Yeah. I liked the steel one, the grid.
Yeah, so
looking at steel's microstructure. That's one of the materials papers.
that one, yeah, very similar to the one that you do in Chemat 121 this
Yeah.
year, where you do the whole grinding, polishing, etching, and then looking at the grains and all that, and relating that to the carbon content of it.
I think that one's pretty good.
Do you get to have good friends with the phase diagrams? So
Oh yeah.
if you
Those
love
phase
that.
diagrams are way bigger than you think they are. They just keep going. And then, so this is sort of like this is like the chemical process side. So it's like, if you think like wastewater treatment, it's like the whole process, and that's where you get like really big diagrams. I saw someone in like 3rd or 4th year had like so many A4 sheets that were actually just this one big diagram, which is a little spooky, but I actually feel like they were
You get
all right.
yeah, you basically get to learn how to like draw those ones called the process flow diagrams. So and they show everything that needs to be done to basically, in this case, produce methanol. So this one here is actually not like, it's very basic design. You get to learn how to create so much more fun designs.
It's pretty cool. So you get to like design a process, so which means you can sort of go into like a lot of areas. This is a
oh yes, there we go.
This is still, I'd say, like a simple process flow diagram. It gets a lot worse. But yeah, Chemat culture, I really like it because it's like 60 to 70 people, and we're quite separate from the other specializations. So like, there's no crossover with anyone else. So you sort of get to know everyone pretty well, and yeah, you become really close with the lecturers.
Yeah.
Like Amanda shows up a lot. I don't know if do you have them in part 1? No. Amanda's great.
Yeah.
She's pretty cool.
Yeah.
And it feels like a 50-50 gender split. I don't know the statistics. It's probably not.
Oh, probably is.
But it feels like it. It's really good. I like it because like all us girls would like sit together, which is really good. And yeah, and the how do you say it? SMESA?
SEMSA.
Chemical Materials Student Association is really fun, and they put on a lot of like tours. So we had the Chelsea Sugar Refinery tour earlier. That was pretty cool. We got to go in, and there's one for a beer brewing place, which we may or may not get to go to. We don't know yet, but yeah. And they put on like pub quizzes and things, which was pretty good. And is there anything else?
Yeah, so they're also really, really helpful with, they also put on a part 2, or no, not part 2, but like a study night, lots of free food, and, the people from the, what do you call it, the older years, they come in and they help out, and it's really good, really social, and you get really involved with everything.
They have some really cool things. We're doing a beer brewing competition at the moment. That's pretty cool. We've just started it, so if you want to like brew beer, I mean, I don't know how ours is going to turn out. Potentially not great, but
oh well.
And then this is like job opportunities. So you can sort of go into like energy, renewable energy is a really good one. Water care, like
food
pharmaceuticals.
processing.
Yeah, food processing is a big one. Sort of go anywhere.
Materials.
So like, I'm currently working at Halter doing something completely unrelated, but yeah, pretty good.
Yeah.
I think, so thanks for listening. If you have any questions, come talk to us.
Yeah. Awesome. Thanks.
Cool, so that brings us to the end of our presentations. Thank you so much to all the speakers. It's hugely valuable for all of the part 1s. Could we get a round of applause for the speakers? And obviously feel free to approach any of the speakers afterwards. We've got pizza outside, and we've got vegetarian, and there's a separate table for vegan or gluten-free.
And regular meat eaters, you're out there too. So everyone is catered for. Thank you guys so much for coming. I hope you guys enjoyed it. And we'll just segue outside and keep on mingling and asking questions. Thank you.
Bye, Zoom people.
to 15 on the Zoom. That's good.
Yeah, that's a decent amount. Yeah, it was like
quite a few
17
people here.
and 15 or something. Yeah, you guys did a good job getting people to come. Yeah, I think it was, you know, Camilla. She's like really organizing like the Discord and like online stuff. So yeah, I think she really pushed that. Like she was like pestering us. She's like, "Is the Zoom link available yet?" Yeah,
She's
sorry,
so
like
good.
it took so long to do that.
Yes.
Oh, that's all right. Stop recording. So like